Welcome back to True North Mechatronics. With our front end architecture complete, we're finally turning our attention to the rear of the vehicle. In this episode, we're designing the Vetronics Platform, the vehicle electronics bay that houses the Arduino Uno, as well as the power distribution circuitry. Mounting a development board isn't just about matching a 4-hole bolt pattern. If you flip an Uno over, you'll see a landscape of uneven through-hole solder joints. You bolt that directly onto a flat plate, you will short the board or crack the PCB. So we are engineering a base plate featuring custom elevated mounting bosses to give those pins proper clearance. Design, engineer, deploy. Let's get to the CAD. We're going to begin by creating a new body and a new sketch on the XY plane. And we're going to outline the shape of our Vetronics platform using our poly tool here. And we are going to be butting up the Vetronics platform against the vertical frame rail. So we need to create some cutouts here for the screws that hold the vertical frame rail onto the pedestal mount. I've got 2 points here that are unattached. I'm going to connect them together using that tool. And I'll just left click and drag that out. And we have a few lines here that we need to constrain horizontally. I'm going to grab those. You can tell that they need to be constrained because they are missing the vertical constraint symbol. So we use this tool to add those constraints. And we've got one line down here that hasn't been vertically constrained, so we fixed that. So we're ready to proceed now with the rest of the constraints. So the first thing that we're going to do is we're going to make this part so that it's symmetric around the origin. And we need to add some collinear alignment locks here. So we're going to do that. Make it so that when we left click and hold and drag, we want these insets to move together, like so. And we're going to make these points so that they are symmetric with respect to the x-axis. So we'll add that constraint there. All right, and now we've got a little bit of clutter here blocking what we're doing. So I'm going to use the hide filter to remove those so that we have a clear view of what we're building. All right, the next thing that we're going to do now is we're going to set it so that these two pockets are going to be equal in width to each other. And let's set the length of these pockets to 7 millimeters. Drag that out so you can see that. Next, we're going to make the depth of the pocket 2 millimeters. Left click on that, and we'll set that to 2 millimeters. All right, so now that we have set our screw pocket dimensions, now we can dimension the top of our Vetronics platform. So this just sits behind all the rest of the hardware that we've built so far. So this is going to be 76.3 millimeters. And we're going to give it a vertical length of 87 millimeters. And we're going to create a distance between our two pockets here of 32 millimeters. And that constrains the overall shape of our platform. Next, what we're going to do is we're going to add a couple of relief holes here. These are the access holes for the caster housing. This holds a caster at the back of the Sparkbot and acts as its rear third wheel. So we're going to set all of these circles so that they have an equal diameter. And we're going to set the diameter on this to 6 millimeters. That gives us a nice clearance hole around the 5 millimeter screw heads on the PT screws that we're using. We're going to make it so that these relief holes are symmetric around the x-axis here. And it has the happy effect of also making it so that these holes top and bottom are collinear. We're going to set these holes so that they are on the same horizontal plane. So if I now move my group of holes, they move in a symmetrical way. We're going to set the distance between these two top holes at 19.5 millimeters. And now we're going to set the distance between our relief holes. We'll set that to 13.5 millimeters. And with that, our pockets are constrained in the vertical direction. We just need to set the horizontal offset distance now. And so let's set that to 9.5 millimeters with respect to the back of the robot. And with that, our shape is fully constrained, so we will close that. And we're going to pocket this shape, and we're going to pad this shape out to 3 millimeters. Next thing that we're going to do is we're going to add the mounting points for the Arduino Uno. It's going to sit on the bottom side of this base here. So we're going to begin by creating 2 circles. And let's set the diameter of both circles so that they're equal to each other. And we'll set that diameter to 2.8 millimeters. Next, we're going to set a distance between these 2 circles. We'll set that distance to 52.25 millimeters. We'll also set a vertical distance between these 2 parts at 32.5 millimeters. And now we have to constrain where on the Vetronics platform this is going to sit. So I'm going to reference this left-hand edge here, and I'm going to click the center of that left hole, and we're going to create an offset of 20.55 millimeters there. And once again, we'll click in the center of that hole, and we're going to create that offset distance and set it to 6 millimeters. All right, so we can see from the solver message that we're fully constrained, so we can close out of the Sketcher workbench, and we can pocket this all the way through. And we'll accept the default of 5, which will clear our 3 millimeter pad. All right, so now we need to add some standoff bosses. This will pick the Arduino Uno up off the Vetronics platform to make clearance space for the through-hole components. So we're going to create a new sketch on the top, and we're going to use our external geometry reference tool, and we're going to reference those 2 holes we made. Now we're going to grab the circle tool, left click in the center of that circle there, and we're going to left click in the center of that circle there. We're clicking on the outside of that shape that we created. So we now have those 2 circles. And again, with the circle tool, we're going to now add 2 additional circles. And these are going to form the thickness of our standoff bosses that the screws are going to attach to. So we're going to set these 2 new circles so that they have equal diameters. And we're going to set the diameter of this to 5.5 millimeters. Now that will give us 2 anchor points to secure the Arduino Uno, but we need to create 2 leveling mounts in either corner to keep the Uno from pivoting back and forth on its 2 anchor points that we created here. So let's create 2 more circles. And the first thing that we're going to do is we're going to set the diameter of both these circles so that they are equal to each other. And we're going to set the diameter of these circles to 4 millimeters. And now we need to lock them into place. So I'm going to click on the center of the 2 left-hand circles. And we're going to set that offset distance to 48.75 millimeters. Zoom out a little bit so that we can see that hole. And then there is an offset distance between these 2 circles here that we need to set. So I'm going to click the center of both circles again. And there we are. There's our offset distance there. We're going to set that to 2 millimeters. Now we're going to click the 2 right-hand circles. We need to make them collinear, so we'll use that tool to constrain them to the same vertical plane. And we're going to set the distance between these two circles at 28 millimeters. And as we can see from the solver message, we're now fully constrained, so we can close out of the Sketcher workbench here. And we're going to pad these shapes that we've created out to 3.5 millimeters. Now this gives us two pedestals here that will keep the Arduino Uno from rocking side to side. What we're going to do right now is we're going to create two pins on these circles, and these pins will go into the other screw holes and keep the Arduino from moving. So you can think of these now as locator pins. We're going to reference that circle, but we're not going to lock our new circles to the outside of those mounts that we created. Once you have those two circles in place, we're going to set them so that they have equal diameters. And we're going to set the diameter of these to 2.8 millimeters. And with that, we have the two pin shapes created. So we can close out of the Sketcher workbench. And we're going to pad out our pins to 2 millimeters. And now we have completed the mounting holes and anchor points for the Arduino Uno that will sit on these points here. The next thing that we need to do is we need to create an anchor point that will tie the Vetronics platform to the Sparkbot base. So we're just going to put a hole underneath the Arduino Uno, and this hole is placed in a location where there are no through-hole pins. So this will not interfere with any of the Arduino's circuitry. So we're going to set that hole to 2.8 millimeters, and we're going to reference the bottom of the Vetronics platform for this. So let's select the bottom edge, and we're going to create an offset distance of 23.5 millimeters. And then we're going to, again, reference that bottom corner, but this time we're going to create an offset distance of 16.3 millimeters. And so this anchor point is now fully constrained, so we can close out of the Sketcher workbench. And we're going to pocket this hole through. Now we need to add a little bit more plastic to this hole just to make it so that the screw has something additional to grab onto. So we're going to create a new sketch, and we're going to reference that circle. And with our circle tool, we're going to select that circle there, and then we're going to add a little bit of plastic on the outside of it. So we're going to make it a boss. And we're going to set the outer diameter of that new circle to 6 millimeters. And so with that, we have now fully constrained that shape. We're going to close out of this, and we're going to add this out to 2.5 millimeters. There we are. And so that leaves 1 millimeter of clearance between the Arduino Uno sitting on top of it and where this screw will be attached. All right, so the next thing that we need to do is we need to create two holes up at the front here that we will use for attaching our switch panel. This will have the on-off rocker switch. So let's zoom in on this area here. We're going to add two circles for that switch panel. We'll be creating that switch panel in a later video. Let's select the two outside circles, give them an equal diameter, and let's set the diameter on this to 2.8 millimeters. And we want these two circles to be collinear, so we're going to select the center of both of them, and we're going to constrain them vertically. Now they move as a group. We're going to set the distance between these two circles at 10 millimeters. And now we need to locate where on the platform we want these circles. I'm going to reference the top edge of the Vetronics platform, and we're going to give it a horizontal offset of 5.5 millimeters. And we're going to give it a vertical offset of 5 millimeters. All right, so with that, we've now fully constrained these two switch mounting anchor points so we can close out of the Sketcher workbench, and we're going to pocket these through, accepting the default of 5. Now we need to create some features on this side of the Vetronics platform that will hold the circuitry for splitting power that comes in from the battery, as well as creating a second level riser for our buck converter, which we will use to condition the battery power to give us 5 volts fed back into the logic board. So to do that, we're going to start by creating 4 new mounting holes. And so let's grab 4 circles, just sort of position them randomly here like this. We're going to make the diameter of all of these circles so that they're equal to each other, and we're going to set the diameter of these circles to 2.8 millimeters. All right, we need these circles to be collinear in the vertical dimension, so they are now collinear. And we're going to create an offset constraint, vertical offset constraint, so 15 millimeters for this one. And this one is just slightly longer. This one is 15.3 millimeters, so that we have our 2 vertical offsets. These move as groups now. Let's set the distance between these 2 groups at 25 millimeters. And now we need to locate where horizontally on this platform we want these locked. I'm going to reference the top edge of the platform for this job, and we're going to select the center of that tool and the right-hand edge there. And we're going to create a 24 millimeter offset for this. Now we just have 2 degrees of freedom. It's the location of that group and that group in the vertical. So we're going to create a vertical offset for this group of 6 millimeters, and we will create a vertical offset for this group of 8 millimeters. All right, so with that, we've now fully constrained these mount points for our control circuitry, our power distribution circuitry. So we're going to close out of the Sketcher workbench, and we are going to pocket these shapes through. All right. Now we need to turn these holes that we just created into mounting bosses. Right now they're just anchor points. So let's create a new sketch on the surface. And we're going to reference those 4 holes that we just made. And with the circle tool, we are going to create 4 new circles. And then just as we did a moment ago to create the mounting bosses for the Arduino, we're going to create 4 oversized holes. Make sure you're clicking right in the center when you do that. Let's select the outside of all 4 of our circles and set them equal to each other. And let's set, just as we did a moment ago, the outer diameter of those bosses to 6 millimeters. All right, so we are fully constrained. We can close out of this, and we're going to pad these ones out to 4 millimeters, slightly bigger than what we did for the Arduinos. Now, the next thing that we need to do is we need to create an elevated platform, and so we need some standoff bosses for the buck converter, and the buck converter will sit on a second level above the logic boards that we attach here. So let's left-click on our platform. And we're going to create a rectangle and a square that'll serve as the basis for our elevated platform. So we're going to put a square right here. And we're going to reference this top edge and this right-hand inset edge. And our rectangle is going to come down here. We're going to make the edge of the rectangle coincident with this point here. And now let's constrain these. Actually, we're going to make this a perfect square, so we're going to set the length and width of this square so that they're equal, so it's a perfect square. And I'm going to set the length of one edge to 6 millimeters. Now I'm going to set the length of the top here on our rectangle to 7 millimeters. And the length in the vertical dimension is 29 millimeters. And our 2 degrees of freedom are the position of our square here. So I'm going to reference this top right corner here. and this top right edge, and I'm going to set this to 38.6 millimeters, and our last degree of freedom is the location of this square along the x-axis. And so I'm going to reference the top of the square, and we're going to offset this by 11 millimeters. And so with that, we can close out of the Sketcher workbench. And we are going to pad these out to 20 millimeters. All right, so there we are. That's what that looks like. And the next thing that we're going to do now is we're going to add a couple of anchor points that will attach the tray for our buck converter. So left click on that top of that pedestal there. And we're going to add 2 holes. There's our second hole there. We're going to, as always, set the outer diameter of both of those so that they're equal. And we're using the same screws, so we're going to set that to 2.8 millimeters in diameter. We want these 2 holes so that they are vertically aligned. They're collinear with each other. We're going to reference the top of this shape here. And then we're also going to set a vertical offset distance between these 2 circles at 21 millimeters. So now we've got 2 degrees of freedom here. And so we just need to locate where we want those circles to be locked. So we are going to position them right in the center of our pedestal that we created here. So that's going to be 3.5 millimeters because it's 7 millimeters in width. And we're going to bring it down from the top. So our vertical constraint is going to be 4 millimeters. All right, so with that, we are ready to close out of the Sketcher workbench, and we will pocket these holes to a depth of 10 millimeters. Now we need to create a clearance conduit here so that the wires leading to the buck converter can get from the power distribution board below it. So we're going to reference the 2 edges of our pedestal there, and we're going to create a square that we're going to use to clear away some of this material, rectangle. So let's give this rectangle a vertical length of 13 millimeters. We don't need to set the horizontal because that's done for us by these edge constraints, but we are going to position this clearance shape right in the center. So it's a depth of 8 millimeters. So we're ready to close out of the Sketcher workbench. And we're going to pocket this shape down to 13 millimeters. So that gives us lots of room for the wires to come up and out. Now the main power lead coming from the battery is going to pass into our distribution board here. And so we want to make sure that that battery wire can't get pulled out of the terminal blocks on the distribution board. So we're going to create some strain relief. And to do that, we are going to create a mounting point here. And so we're going to reference this right-hand edge here. And we're going to create a circle. This is going to be used for attaching some strain relief. Let's set the outside diameter of this to 2.8 millimeters. And just as we did a moment ago, we are going to position this in the center with an offset of 3.5 millimeters. And this one is going to be up from the edge at a vertical offset of 4 millimeters. So there we go. There is our strain relief anchor point, fully constrained, so we can close out of this. And we are going to pocket this anchor point to a depth of 8 millimeters. And we have now completed the shapes on our main Vetronics platform, but now we need to build out the tray that sits up here that's going to hold our buck converter. So we're gonna rename this part here, and we're just going to call that the logic platform. And we're going to collapse this here in the model tab. And the next thing that we're going to do is we're going to come up here and we're going to create a new body. And in this body, we're going to use this particular tool to reference the tops of the pedestals that we've created to hold the buck converter's tray. So once we've done that, we're going to click on this tool right here. So that is the subshape binder. And you can see that the subshape binder showed up here under the body. I'm now going to hide the logic platform and leave just the subshape binder here. And we're going to now left click on this. You can see that the binder is highlighted here, and now we're going to create a sketch. And we're going to outline what that tray is going to look like, but we're going to reference these two edges here. This one here and this one here. So there we are. Okay, so let's grab the polyline tool and we're going to come out like this, down and over and in, up, in, and you got to make sure that you close your shape. All right, so you'll notice that I did this carefully enough that I have got these horizontal and vertical lock lines there. If those lock lines are missing, then you will have to constrain. All right, so let's set the horizontal constraint here at 54.5 millimeters. And we're going to set this value here at 6 millimeters. Before we close out, we're going to have to also reference these circles here. So we're going to reference our two anchor points and going to create circles there. So now we're fully constrained. We can close out of the Sketcher workbench and we can pad this out to 3 millimeters. Now the next thing that we are going to do is create some clearance pockets for the through hole components on our buck converter. And we've got two main sets of clearance holes that we need to create. So click on the top face of your tray and create a new sketch. And we're going to create 4 squares. And these squares are going to all be equal to each other. So we're going to grab a horizontal base for each one of those squares, and we're going to set them equal to each other. We're going to do the same thing for a vertical face on each one of the squares. We're going to set them equal to each other. If I change one, now they should all change. And the next thing that we're going to do is we're going to set one face equal to another. And this will make it so that they all work as perfect squares now. All right. The next thing that I need to do is I need to make these squares so that they are horizontally and vertically collinear. So I'm going to select these 2 points here. And I'm going to set them locked so that they're vertically collinear. I'm going to do the same thing with the 2 edges of the squares over here. And now I'm going to make these squares so that they are horizontally collinear. And we'll do the same with the bottom squares. And now we have a whole mess of constraint lines here, so I'm going to hide these so that I'm just looking at the squares. I'm going to set the width of one of these squares to 3.5 millimeters, so all of the squares will now be 3.5 millimeters squared. I'm going to set the distance between these 2 outer points to an offset of 21 millimeters. And I'm going to do the 2 outer points at the bottom, and that's going to be set to 43.5 millimeters. Now we can locate where we want these clearance pockets to sit. I'm going to reference the left-hand edge of the tray here. And with these 2 points selected, I'm going to create a vertical offset of 4 millimeters. And a horizontal offset of 2.5 millimeters. And with that, we have fully constrained the clearance holes for this set of clearance holes on the tray. So we're going to close out of this and we're going to pocket those shapes through. We'll accept the default of 5. And now we need to create 2 anchor points. This will be what we use to secure the buck converter to the tray. So we're going to create 2 circles. These are screw anchor points. We'll set the diameter of both circles so that they're equal to each other. And we'll set the diameter to 2.8 millimeters. Now we're going to create a horizontal offset between these 2 circles of 30.5 millimeters. And the horizontal offset, we'll set that to 16 millimeters. And now with our 2 degrees of freedom, we are just looking to position this on the tray. So we're going to reference the left-hand edge again. We're going to reference these 2 points here, and we're going to set that to a distance of 6.5 millimeters. And then the horizontal offset will be 9 millimeters. And so with that, we fully constrained our 2 anchor points for the buck converter, so we can close out of the Sketcher workbench, and we can pocket these shapes all the way through. Now we need to create another clearance pocket, and this is going to be for the through-hole pins on the potentiometer variable resistor that is used for setting the output voltage of the buck converter. So we're going to create a rectangle, and we're going to give it a horizontal dimension of 9 millimeters and a vertical dimension of 3.5 millimeters. And now we need to locate it on the tray here. So we're going to reference the left-hand edge of the tray, and we will give it a horizontal offset from the edge of 13 millimeters. And we will give it a vertical offset of 6 millimeters. And as we can see, we are now fully constrained, and so we can pocket this clearance hole all the way through. And we're going to rename this part to we'll call that the buck tray. We're going to collapse this in the model view now, and we are going to hide the buck tray, but we're going to bring back the logic platform. And let's select the base where the strain relief is going to go. And we're going to create a new body. So there's our new body there. I'm going to rename it strain relief. So strain relief has been selected. I've selected this face here, and now I'm going to click on subshape binder. There's our subshape binder. I'm going to hide the logic platform and leave just the subshape binder showing. Left click on that, and we're going to create a sketch. Now we're going to reference the 2 outer edges of our shape and our anchor point. So let's create a square that's coincident with these corner points. Let's create a circle that's coincident with the anchor. And we can close out of the Sketcher workbench. And we're going to pad this shape out to 6 millimeters. We need to create a little pocket here that will allow the battery wire to slide under. So we're going to create a sketch on this face here. And we're going to reference the edge of our shape. So let's grab our rectangle tool. Let's create a rectangle. Let's give it a horizontal dimension of 5 millimeters and a vertical dimension of 2 millimeters. And we're fully constrained, so we can close out of this, and we're going to pocket this shape all the way through and give it a dimension of 7 millimeters, so that shape is now pocketed all the way through. And so when we look at how all of these fit together, now we can see that we have a complete logic tray assembly. We've got a spot for the buck converter and a spot for the Arduino Uno. And that completes the Vetronics platform. We now have a dedicated fully electronics bay that properly clears our through-hole components, minimizes our fastener count, and anchors brilliantly to the foundation we laid back in part 1. Seeing this platform slot in right behind the vertical frame rail and tuck under the battery box really shows how dense and efficient this chassis architecture is becoming. In a future video, we will tackle the main power switch panel. I made the deliberate engineering decision to keep the switch module mechanically independent from this Vetronics plate, but just like today's anchor point, the mounting holes for that switch were already integrated into the mobility base on day 1. System level planning always pays off. Chart your course, build your world. I'll see you in the next one.